This video is on distance, displacement, speed, velocity, and acceleration. Here are the understandings. Question 1. What is the meaning of 0 dimensions, 1 dimension, 2 dimensions, 3 dimensions, 4 dimensions? If possible, draw a figure for each. So 0 dimensions means a dot, an infinitely small dot. You can't do anything. Can't go left, right, forward, backwards, or up or down. 1 dimension is a line, has units of meters. 2 dimensions is a plane, P-L-A-N-E. So an example is a piece of paper. You could go left, right, up or down. That's it. 3 dimensions, it has an X, Y, and Z axis. It can go left, right, up, down, into the page, out of the page. It has units of meters cubed. 4 dimensions is 3 dimensions in space and 1 dimension in time. So it has units of X, Y, Z, T. So an example of 4 dimensions is today there is a donut at a certain location, and in 72 hours the same location X, Y, Z, but a different time 3 days later, there's not a donut, there's a cookie. Question 2, define position. Position is a location of an object or point. So they're going to give us an X or an XY or an XYZ. Question 3, define distance. Is it a scalar or vector? Units example, can distance be negative? Distance is the length from one position to another position. It's a scalar, has units of meters. Can never be negative. Question 4, define displacement. Is it a scalar or vector? Units example, can displacement be negative? Displacement is a distance in the direction from one point in space to another point in space. It's a vector, has units of meters. An example is 34 meters, 56 degrees north of east. And yes, displacement can be negative. So understand the difference between distance and displacement. Question 5, define speed. Speed is a distance an object travels per unit time. It's a scalar. Its equation is total distance traveled divided by total time taken. Has units of meters per second. It cannot be negative. Question 6, define velocity. Velocity is the displacement an object travels per unit time. So it's a total displacement divided by the total time taken. So look at the equation for speed. It's total distance over total time. Velocity is total displacement over total time. Speed is a scalar. Velocity is a vector. You see, velocity gives us the direction. And yes, velocity can be negative. Question 7, define average speed. That's the total distance an object travels per unit time. It's a scalar. Define average velocity. That's the total displacement an object travels per unit time. It's a vector. Question 9, an object moves in a circle with a radius of 3 meters. It takes the object 4 seconds to complete 1 revolution. What is the average speed and average velocity of the object after it completes 1 cycle or 1 revolution? So our average speed is total distance over total time, and we get a non-zero value. The average displacement is going to be 0 because our initial position and our final position is the same. So the total displacement is going to be 0. Part B, what is the average speed and the average velocity of the object after it completes 1/2 cycle? So remember, it took 4 seconds to complete 1 revolution. So it's going to take 2 seconds to complete half a revolution. The average speed is total distance over total time, which is 2 pi r divided by 2, divided by the time taken, which is 2 seconds. We get a non-zero value. And the average velocity is going to be the total displacement. What is the radius of this circle? It's 3. So if it goes from one point to another point, it's going to have a total displacement of 6 meters west. So it took 6 meters west divided by 2 seconds. So the solution is 3 meters west for the average displacement, or the average velocity, sorry. Question 10, an object starts from rest at point A and then travels to point B by moving north 1 meter, then east 5 meters, and finally south 1 meter in a total time of 14 seconds. What is the average speed and average velocity of the object when it moves from point A to point B? So you can see the average speed, the total distance is 7 meters. The average velocity, the total displacement is 5 meters. Because the displacement, we only care about the beginning position and the final position. For distance, we care about the total distance taken. And you can see average speed doesn't have a direction. Average velocity does have a direction. Question 11, define instantaneous speed. That's the speed of an object at a specific time. Question 12, define instantaneous velocity. That's the velocity of an object at a specific time. Question 13, define acceleration. It's when an object speeds up, slows down, or changes direction. So acceleration is delta v over delta t. It has units of meters over seconds squared. Memorize that. So velocity is what you're doing. Acceleration is a change of what you're doing. Example, the acceleration of the car is 2 meters per second squared west. That means the object is changing its speed 2 meters per second every second in the west direction. Question 14. What is the magnitude of the acceleration of free fall g near the surface of the Earth? What direction or way does it point? Is it positive or negative? So sometimes students ask, teacher, is it positive 9.81 or negative 9.81? That's not the question you should be asking. The first question you should be asking is, what is positive y? Is positive y up or down? If positive y is up, then g always points down towards the center of the Earth. Since those directions are opposite, g is negative 9.81. If you're saying positive y is down, and g is always down, points straight towards the center of the Earth, then they're pointing in the same direction, so g is positive 9.81. So the first step you need to do is decide whether you want positive y to be up or down. And then that'll tell you whether g is positive or negative. Question 15, define projectile motion. That's when you throw an object in the air, there's no force of friction, and there's no engine or anything that's going to make the object like speed up or slow down. The only force is a force of gravity. So in projectile motion, the object could be going up, down, left, right, in any angle. You could drop it, you could throw it up, you could throw it at an angle. Question 16, what does the slope of a displacement versus time graph tell us? Well, what's the slope going to be? It's going to be, well, it's going to have units of meters over seconds. What is meters over seconds? That's the velocity. So the slope of a displacement versus time graph tells us the velocity of the object at that specific time. So if we take the slope of this curve at all these different points, it's going to tell us the velocity at all these different times. So this red line tells us, if we take the slope of this red line, it's going to tell us the velocity at this point here on this black curve. Question 17, what does the slope of a velocity versus time graph tell us? Well, for this black curve, the slope, which is this red line at this point, is going to have units of meters over seconds, which is the acceleration. So the slope of a velocity versus time graph tells us the acceleration of the object at that specific time. Bam, here. Question 18, what does the slope of an acceleration versus time graph tell us? Well, it's going to have units of meters over seconds squared divided by seconds, which is meters over seconds cubed, which is called the jerk. And for IB physics, A-level physics, AP physics, even if you have a bachelor's in physics, you're not going to learn about jerk. I'm sure you won't. Question 19, what does the area under a displacement versus time graph tell us? Well, its units is going to be meters times seconds. Meters times seconds is something we don't know anything about, so it doesn't tell us anything. What does the area under a velocity versus time graph tell us? Well, what are the units of this area? It's going to be meters over seconds times seconds, which is meters. So the area under a velocity versus time graph tells us the change in displacement between these two times. What does the area under an acceleration versus time graph tell us? It's going to have units of meters over second squared times seconds, which is meters over second. So the area under this graph is going to tell us the change in velocity between these 2 points. Between these 2 points in time. Question 22. How would he go about determining the acceleration due to gravity near the surface of the Earth? Okay, so will y initial be above the surface of the Earth? We'll say that's 0 meters. We'll say y final is the surface of the Earth and positive y points down. So y initial is 0, v initial is 0, that means we drop an object from rest. And y final is the total distance fallen. So we need an object like a ball, a stopwatch, and a ruler. So we'll go to a location where there's little air friction. We'll measure the vertical distance. You will drop an object. We will drop the object and measure the time it takes for the ball to be in the air. We'll do this 10 times and then take the average time for more accuracy. And then we're going to use this equation and solve for the acceleration. Okay. We know y initial is 0. We know v initial is 0. So just take this equation and just solve for a. So the acceleration due to gravity near the surface of the Earth is this equation. That's how we find the acceleration due to gravity near the surface of the Earth. So now let's determine distance, displacement, speed, and velocity. Somebody runs from point A to B to C to D back to A at a constant speed in 43.03 seconds. So the total distance traveled from A to B is 100 meters. From A to B and B to C is 200 meters. A to B, B to C, C to D is going to be 300 meters. And finally, A to B, B to C, C to D, D to A is going to be 400 meters. The total displacement, remember, it's going to be the distance from A to B, which is 100 meters. And that's going to be north. Then it's going to be the distance from A to C. We're going to have to use Pythagoras' theorem. This is going to be the square root of 100 squared plus 100 squared, which is the square root of 2 times 100 squared. So that's going to be 141 meters at 45 degrees north of west. Notice the difference between displacement and distance. Now, what's the displacement from going from point A to point D? That's going to be 100 meters west. And finally, returning at point A, it's going to be 0 meters. Why? Because we're going to go from point A to point A. For displacement, we only care about the original position and the final position. The average speed that it takes to go from point A to point B is 43.03 seconds divided by 4. Then from point A to point C, it's 43.03 seconds divided by 2. Then from point A to B to C to D, it's 43.03 seconds times 3 over 4. So you could see what was done for average speed. We have 1/4 here, 2/4, 3/4, and 4 over 4. The average speed is the same, 9.30 meters per second. Now look at the average velocity. Well, the numerator is going to be displacement. It's not going to be distance. So here you have 100, 200, 300, 400. And that's what we have in the numerator here, 100, 200, 300, 400. What we have in the numerator for average velocity is this, 100, 141, 100, 0. 100, 141, 100, 0. So you see the velocity decreases to 0 because we end up going to the original position. Question 2. Now we're going to go from, now we have a rectangle. So we have the same type of question. Determine the total distance traveled from point A to B, from A to B to C, from A to B to C to D, and then finally from A to D, finally from A to A. You could pause the video and see how this problem was solved. Question 3, now we have this traditional track where the semicircles have a length of 100 meters and the straight part has a length of 100 meters, totaling 400 meters. So you could pause the video and see what was done to determine the total distance and the total displacement. Then you could pause the video and see how the average speed and average velocity were calculated. You could see the average speed is the same, average velocity changes. As you could see, it decreases. Finally, for question 4, we're running around a track that's going to be a circle. The circumference or the perimeter of the circle is going to be 400 meters. You could see how the total distance and the total displacement and the average speed were calculated. And you could see how the average velocity was calculated. Please do take a break and play this video game. It's really fun. You should play it with your physics friends and physics teacher.